Longest span in two binary arrays. Difficulty is medium. Um, well, let me say something about the medium. It's not really a complicated algorithm, but it is the kind of algorithm that if you hadn't seen it before, it would be hard, I think, to come up with it on the fly in an interview. So, okay. I guess that's where we get medium, is that the, it's a combination of hard to come up with on the fly, but really, not that complicated. The math is a little bit, it's not super intuitive. All right, so that said, here's the problem. Given two binary arrays, A1 and A2, find the length of the longest common span, ij, where j is greater than or equal to I, such that A1 at I plus A1 at I plus 1, etc., plus A1 at j equals A2 at I plus A2 at I plus 1, etc., plus A2 at j. All right, well, how does that work? Let me see if I can get a pen here just for a second. All right, so this one here, the longest span with the same sum in both arrays is from index 1 to index 4, right here. So those both add up to 1. So the solution is 4. All right, anything else that we need to know here? Size of the arrays. Size of the array, they'll both be the same size. Size can be up to 1 million elements, which suggests that a linear algorithm would be good, and that's the expected complexity. Topic tags. Usually they have the company tags here, like what company or companies like to ask the question. They don't have that here. Prefix sum. Yes. Sliding window. Yes. And then the others are just pretty standard. All right. So actually, I would like to kind of walk through this by hand once, because before writing the code, because I think that will make more sense. Let me set it right here and pause for a minute while I set up the variables. All right, here's the variables. The first thing we need a difference array. That's what you see across the top there, numbered from 0 to 13. Wait a second, we don't need, it needs to be a 13 element array, but we don't need element 13. The difference array is, it's going to store the first occurrence of each possible difference between the running sums of the two arrays. Running sum means we're going to iterate through both arrays at the same time, and we're going to keep a running total of 1 plus, we're going to keep a running sum of each array, and those are going to be kept in variable sum1 and sum2. The difference is going to be sum1 minus sum2. Could do it with sum2 minus sum1. It doesn't really matter, but the arrays in this case are a length of 6. Why do we have a 13 element difference array? Well, the reason is that the sums can be anywhere from, in a 6 element array, sum1 could be as high as 6, and sum2 could be 0. That would be a difference of 6. Or sum1 could be 0, sum2 could be 6. That would be negative 6. So the difference is going to be in a range of negative whatever the length of the array is, in this case 6, -6 to +6, and including 0, so that's 2n plus 1 needs to be the length of the difference array. We initialize all of the elements of the difference array to -1 just to indicate that we haven't processed them yet. We initialize sum1 and sum2 to 0, and we initialize max span, which eventually will have our answer in it to 0. All right. Let's see. We're going to iterate through the arrays. All right. So let's start with that. Sum 0. Oh, I got to keep track of the index. I. We're going to start with I is 0, and at index 0, sum 1 is 0. At index 0, sum 2 or array 2 has a 1. So sum 2 now becomes 1, right? We got to calculate the difference. Sum 1 minus sum 2 is 0 minus 1, -1. But again, we have to adjust that for the fact that really this element right here, 6, is represents a difference of 0, and then we have the differences going down here, -1, 2, 3, 4, 5, 6, or +1, 2, 3, 4, 5, 6. So 0, -1, -1. To adjust it, we add n, the length of the array. So 6 minus 1 is 5. All right. First thing is we check the current difference. The current difference is actually -1. If -1, I'm sorry, but the adjusted difference is 5. So let's look at 5. Let's see if that equals -1, meaning we haven't seen it yet, and we haven't. And if that is the case, we put the current index in there. So this is now gone and replaced by the current index I, which is 0. Okay, next go to I is 1. So sum 1 is going to become, since we're adding 1, it's going to be 1. Sum 2, since we're adding 0, is also 1. Now the current difference is 0. Okay? If the current difference is 0, we handle this a little bit differently. What we do is we set max span to index plus 1. The index is 1, and we set max span to 2. Well, that makes sense if we're here and there's no difference between the running sums. We just add 1 to make up for the fact that we have a 0 indexed array. So right now our max span is 2. We have 0, 1, we have 1, 0. Okay, go to the next index, 2. That is 0 here, so this stays at 1. It's 1 here, so this goes to 2. Current difference is sum 1 minus sum 2. That's -1. But the adjusted difference, and I should be writing this down here, the adjusted difference is n plus the difference. So 6 minus 1 diff is 5. Is 5 equal to -1? No, we've already processed the difference of -1. So what we do is calculate, I should have another variable for this. Let me put it here. Let me put a length variable. All right, the length is going to be the index minus the difference array at the diff index. So the diff index is 5, and the array there is 0. So 2 minus 0 gives us a length of 2. Is that greater than max span? It's not. So we're going to move on. This is now going to go to 3. Let's see. 3, it's 0 in both of these arrays, so they stay the way they are. This is still going to be -1. The adjusted diff is still going to be 5, and we are going to calculate length again as index minus the difference index at diff, which is 0. 3 minus 0 is 3. Is that greater than max span? Yes. All right, put it in max span. Why does that work? Well, because now we do have a 3-element array with the same sum from here to here and from here to here. Okay? Next index, index 4. Let's see, 4 is 0 and 0, so the sums are the same, 1 minus 2. -1 is the difference, the adjusted difference, n plus the raw difference, n minus 1 is also 5. So we check in here and find a 0. Calculate the length. Index minus 0 is 4. Is that greater than max span? Yes. So let's put it in there. 4. That works because we now have a 4-element span with the same sum. And now we are going to bump the index to 5. All right. Over here, the index of index 5 in A1 is 0, so that stays at 1. Index 5 in A2 is 1, so that goes to 3. The difference now is 1 minus 3. That's -2. The adjusted difference is n plus the raw difference. So 6 minus 2. Our diff is 4. So what we're going to do is look in here and at index 4 and see we haven't processed that yet. So we'll put the current index in here, and that's all we're going to do for now. And in fact, we've come to the end of the array, and we have our max span. It's right here, 4. So let's take a look at what an implementation of that would look like. All right, I typed the code in rather than having you watch me type it in, but here's what we got. N will be the length of the arrays. Max span is initialized to 0. Here is our difference array, length of 2n plus 1. And we initialize all the elements to -1. Initialize sum 1 to 0. Initialize sum 2 to 0. Now here's our loop. We go through the arrays and add the digits one at a time. Each time we add a digit, we check for the current difference, sum 1 minus sum 2, and then we do this adjustment to get an index into the difference array. Now, if the current difference is 0, that means that we've gotten to a point in the array where the whole array up to this point, both arrays up to this point have the same sum. So we can say that the max span is current index plus 1. Now, if the current index is not 0, we look in the difference array and see, have we encountered this particular difference before? Like we encountered a difference of -1 twice. Let me move this over again. So we encountered a difference of -1 actually at index 0. We encountered a difference of -1 at index 2. But we want the first one. we want the first one because that's the one that we want to throw out and start the new count. So when we threw out the mismatch here, we threw out the mismatch at index 0 and just started over again at 1. And we did get 4 in a row matching at 1. So if this particular difference hasn't been seen before, then we put that index into the difference array. So in the example, we put index 0 into the difference array. Now, if the difference array at that index is not -1, that means we have seen it before. And that is where we want to start counting from. So we take index minus the diff at the diff index. And you saw that as we went through here, the diff didn't change. It stayed at 0. So the index just went up, but the difference the difference in the difference array stayed the same. So it just kept going up to 2, 3, 4. And if it's greater than max span, then we put max span in length. Let's see, is there anything else I wanted to say about that? No, I think that's it. But this is kind of a tricky part here, is the index minus the difference array at the diff index. When we did this, the diff index was -1 from index 2 to index 4. And what we had in the difference array for the difference of -1, or the adjusted difference of 5, was 0. That was the first -1 mismatch that we saw. So we can just start from there. That's the starting point. The current index is where we are now. Do the subtraction, and that gives us the matching span. So, okay. Oh, you know what? I didn't even run this yet. I'm talking like it's done. All right, let's submit it and see what happens. Okay, good. All right, that's it. Please like the video, subscribe. You'll get notifications when I put one of these up, which I hope to be every weekday. And see you next time.